Our speaker today is Mr. Andrew Chaikin. Mr. Chaikin is an independent space historian, best known for the author of being the author of A Man on the Moon: The Voyages of the Apollo Astronauts, widely regarded as the definitive account of the moon missions. Published in 1994, the book became the main basis for Tom Hanks's 1998 Emmy Award-winning HBO miniseries From the Earth to the Moon. He has been a visiting instructor at NASA since 2010 and has taught principles of success in spaceflight, his class on human behavior lessons for spaceflight projects, to approximately 2,000 spaceflight professionals at the DoD's Missile Defense Agency and other organizations. A graduate of Brown University with a degree in geology, Chaikin served as the Viking missions to Mars, served on the Viking missions to Mars at NASA's JPL, and was a researcher at the Smithsonian Center for Earth and Planetary Studies before becoming a science journalist in 1980. Since 2015, he has been a member of the Geology, Geophysics, and Imaging team of the New Horizons mission to Pluto and the Kuiper Belt. He is also a member of the NESC Human Factors Technical Discipline team. A former editor of Sky and Telescope magazine, Chaikin has also been contributing editor of Popular Science, has written for Newsweek, Air and Space, Smithsonian, World Book Encyclopedia, Scientific American, and other national publications. He is a co-recipient of 2 NASA Group Achievement Awards for his participation in the Viking and New Horizons missions, and is a recipient of the American Astronautical Society's Ordway Award for Sustained Excellence in Spaceflight History. And with that, I am very pleased to turn over the webcast to Mr. Chaikin.
Thank you, Lee. Thank you very much. And it's great to have a chance to be with you all and to present this fascinating material. Before I begin, I want to just point out that this study that I'm going to talk about today is about to be published on the NASA Technical Report Server. However, if you decide to go look for it, please look also for the subtitle of the study rather than just Humans to Mars, but How Many, because that happens to be also be the title of the entire NESC study of which it is a part. Okay, so just to give you some background, I'm going to talk about a study that I conducted last year, a historical review of past studies of human missions to Mars, with an emphasis. In other words, the studies that I examined included the thinking that went into recommendations for the size of the crew. Now, I was asked to conduct this review to support an effort by the NESC, the NASA Engineering Safety Center, which has been underway for several years now and has just recently reached its first conclusion. There will hopefully be more work, but they are about to publish the results of a multi-year effort to develop a tool, an analytical tool, to help decision makers determine the optimum crew size for human Mars missions. Now, this is a very much needed effort that has really the need for it, as you'll even see in the studies I'm going to tell you about, that need became apparent long ago. And it's great that it has now reached a point where the space community can learn about it and find out what it, just everything that it can assist with. So, I love the comment by NASA mission architect John Connolly, who wrote a paper about human missions to Mars and creating an architecture for those missions. And they said, he and his colleagues said that human Mars missions are so demanding and complex that they really qualify as the ultimate systems challenge. And it's really, really true. So in particular, the things about a Mars mission that prompted the NESC's effort to create a crew size determination tool was an understanding that really, when you think about it, Mars missions stand apart from all previous human space flights for two reasons. For one really critical reason, which is that because of the vast distances involved and the time that is required for radio signals to travel between the Earth and the crew of the Mars mission, that can be up to 22 minutes one way. That means that the enormous expertise of the teams in Mission Control, the Mission Control Center, including all the back rooms there, that expertise that all previous NASA flight crews have relied upon will be unavailable in real time. So that means that it will be critical to choose a crew size large enough to provide the necessary onboard expertise to solve unanticipated problems. So this is just an overview of the studies I considered for this historical review. There were 15 studies between 1948 and 2021 that gave some attention to the issue of crew size and revealed some of the evolving thinking that went into that determination. So we start more than 75 years ago, more than 3/4 of a century. It's kind of amazing to think that it's that long ago that Wernher von Braun conducted the first engineering study of a human Mars mission. You may know that von Braun and many members of his rocket team that worked under Nazi Germany in World War II had surrendered to the Allies at the end of the war and had been brought to the United States to jumpstart this country's guided missile programs. Von Braun in 1948 had a little bit of time on his hands and decided to put down on paper his thinking about how you would send humans to Mars. That study was later published in book form as The Mars Project, the English title, and also there was a previous German edition. Now, if you look at von Braun's plan for this Mars expedition, it is no less than staggering. He may have been influenced by some of the Antarctic expeditions that were underway at that time, but he envisioned 70 people as the crew of that expedition, with 50 of them landing on the surface. And the total expedition mass is 88 times that of the completed International Space Station. So we're really talking about a titanic effort here. Now, that was in 1948. By 1954, that plan was being put in front of millions of magazine readers in this country, readers of the magazine Collier's. And you can see on the right, the cover of the April 30th, 1954 issue of Collier's, which includes von Braun's article about his Mars expedition. And the cover is beautifully rendered by the founding father of space art, really, Chesley Bonestell, from von Braun's own drawings. So that really popularized von Braun's plan. 2 years later, in 1956, von Braun co-authored a book with the German-born writer Willy Ley called The Exploration of Mars. And it's interesting to see that by that time he had scaled back his plans. Now the expedition included a crew of 12, with 9 of them landing on the surface. For our purposes, the interesting nugget there is that von Braun did talk about the roles of the crew and the things that they would have to be responsible for. And he noted that at any given point, a crew member, any of them, could be incapacitated by illness or injury, which meant that you had to cross-train crew members to cover each other's responsibilities in case that actually did happen. He also advised that 3 of the 9-person surface crew should be trained in medicine and simple dentistry. Okay, well, NASA, of course, was created in 1958 with the goal of putting Americans in orbit with Project Mercury. But here we are in 1963, and the agency is already looking ahead to trying to figure out how you would someday send humans all the way to Mars. Now, of course, by this time, the Apollo program was well underway to put humans on the moon, but this is, of course, an even more far-reaching effort. So two NASA centers, the Ames Research Center and the Manned Spacecraft Center, which later became known as the Johnson Space Center, later renamed in Houston, they both funded contractor teams to conduct studies of human Mars missions. Now, one of those teams, interestingly, conducted what they called a brief human factors study, which included an analysis of crew tasks. And from that brief human factors study, they concluded that you could do the mission, that an 8-person crew was, quote, desirable, and a 7-person crew was a minimum. But in their report, they set a baseline of 6 crew. Now, they did note that if you could improve the reliability of the systems, the subsystems on board the spacecraft, then that could allow for smaller crew sizes. Another of these contractor studies was focused on the transit vehicle that they would ride to and from Mars and, of course, be in Mars orbit. That study actually warned that maintenance tasks could overwhelm the crew's time at the expense of the science activities that were basically one of the primary purposes of the mission. So it's interesting to see that here at this early date, we already see some insight into what the workload of the crew could be and how that could impact the science that comes out of the mission. Now, the third team studied a Mars lander. And interestingly, they actually contradicted the 2-person crew baseline that they were given, apparently by NASA. And they said, no, we think 3 crew would be required to obtain, quote, a reasonable scientific and engineering data return from the surface of Mars. Now, we've jumped ahead 3 decades. And it is actually true that there were no real studies of Mars missions. There were plenty of studies of Mars missions in between those times, but they didn't focus on crew size and the issues that we're interested in here. So now we're in the early 90s. And in the early 90s, a human factors specialist at Ames named Yvonne Clearwater analyzed the minimum crew size needed to achieve the combined science and habitability objectives of the Mars surface mission. So she focused on surface mission skills. You can see on the right the chart that was included in her commentary, which was presented in 1992 at a workshop that was held at Ames called the Mars Exploration Study Workshop number 2. That the results of that workshop were then published the following year in 1993. So Clearwater identified a wide range of tasks that would be required for the surface mission and roles, crew roles, and she conducted what she called a workload analysis. However, no details were given about the methodology used for that analysis. But you can see on the right the spectrum of things that the crew would have to accomplish, all the way from, things like operating the vehicle, maintaining the vehicle, making tools, to, in the middle column, the science activities, and then on the right, more things ranging from, maintaining the IT, the computers on board, databases at that time they were envisioning, preparing food. If you're going to have a greenhouse on Mars, you're going to be operating that. You're going to be creating food from that and meals. Then things like navigating across the surface. You may have teleoperated rovers, and even things like journalism and housekeeping were considered. So from that analysis, Clearwater concluded that the surface mission can be conducted with a minimum crew size of 5 based on the technical skills required. And she noted that each astronaut would be assigned a primary role with at least one other crew member serving as backup. However, this is a very important caveat. She pointed out that loss or incapacitation of one or more crew members could significantly jeopardize mission success. Therefore, a minimum crew size of 7 or 8 may be required to address the risk issues. However, the workshop baselined a 6-person crew. Now, that number became a paradigm that lasted quite a long time, as we'll see. Here we are in 1997, and NASA is publishing the first detailed mission plan for a human Mars mission. They call it Human Exploration of Mars, the reference mission of the NASA Mars Exploration Study Team. It's also known shorthand as the Design Reference Mission. Now, this Design Reference Mission is intended to serve as a kind of foundation for future efforts to plan human missions to Mars. In the report, they basically repeated the crew size recommendations that Yvonne Clearwater had spelled out in the 1992 Ames workshop. They again baselined a 6-person crew, but acknowledged that, again, a larger crew may be necessary to reduce risk. But it's noteworthy that this design reference mission focused mostly on tasks that would have to be accomplished during the voyage to and from Mars and in orbit around the planet. In other words, the workload of the crew in the transit hab. And surface activities received relatively little attention. They noted the need for highly autonomous systems because of the lack of real-time support from Earth. And they said that the amount of system automation, the level of system automation that could actually be achieved with existing technology would be a very important consideration for crew size. So, here we are in 1997, and we're a long way, quite a long way from having those highly autonomous systems, but the authors of this study recognized the need for them to carry out the mission. They also cautioned that any crew needs that were not anticipated before the mission would significantly challenge the management and operation systems to support the crew. So here they're talking about mission control. They're talking about the support rooms that help mission control. They're talking about the training folks. Everybody on the ground who supports the crew will have to deal with unanticipated needs that arise during the mission. Okay, now we're in the late 1990s, and NASA headquarters, the Office of Exploration at NASA headquarters, has recruited members of the Johnson Space Center's Mission Operations Directorate, which of course includes all of the flight controllers, flight directors, the people that support them, the people that do trajectory analysis and all of that good stuff. All of those people, members of that directorate, are recruited along with other specialists from JSC and the Kennedy Space Center to form something called the Human Exploration Operations Team to carry out a human Mars mission study. Interestingly, they are given a requirement that the mission be, quote, economically feasible. Now, that mandate then led them to challenge this 6-person crew baseline that had originated with the 1992 Ames workshop, had been baselined by the 1997 design reference mission. Now that is being challenged. So this team examined, would it be possible to conduct extravehicular activity, EVA, on the surface of Mars safely and successfully with a 4-person crew? Now, to answer that question, they studied past experience of EVA in low Earth orbit, US experience, and the experience of Soviet and Russian cosmonauts. Their report was issued within NASA in 1999 and then revised in 2000. So the results of that analysis, their plan envisioned that Mars surface EVAs would be conducted by this four-person crew split up into two pairs of astronauts who would do EVAs on alternating days. And they wrote that while one pair was outside, the second pair would remain inside with one individual performing intravehicular IV support and the other monitoring vehicle health and status. Now, I've emphasized those words to put a flag on that because it is really worth noting that they are calling on one person to do the work of what up until then and still today is carried out by not only multiple humans on board something like the International Space Station, the IV crew that's in orbit while the EVA crew is outside, but also, of course, as we've been saying, literally dozens of people on the ground, whether they're in the Mission Control Center or they're in the various back rooms that support the mission control room. And so we're really, this really deserves scrutiny, whether or not that is a reasonable leap to make. They concluded that four crew was, quote, operationally sufficient, and that it does not incur a substantial increase in exploration EVA risk to the crews. But there was a member of their own team who challenged this conclusion for being too success-oriented. This person basically pointed out that, you can do it with four crew if nothing goes wrong. But of course, the whole experience from the beginning of the human spaceflight program is that things do go wrong. So they challenged this conclusion, and that resulted in the report including a number of caveats, acknowledging that a four-person crew, quote, may not be optimal for mission success due to the possibility of illness or incapacitation. And they added, they also noted that adding another crew member might be required to handle the spectrum of required skills. But they also said that, quote, to realistically determine the crew size, a trade must be made between the costs associated with one additional crew member and the level of risk which is considered acceptable for achieving mission success. That's a very significant statement. It spotlights the fundamental tension that exists in the planning of any human Mars mission, that tension between the cost of sending a given size crew versus the risk of sending sending a crew large enough to make the risks down to an acceptable level. Okay, now we're in 2009, and NASA has revised the 1997 Design Reference Mission to create something called the Design Reference Architecture 5.0. Now, like its predecessor, the 1997 Design Reference Mission, the 2009 report again baselined a six-person crew. They called it, quote, a reasonable compromise between costs and the level of onboard expertise required to successfully carry out the mission. But there was a lengthy addendum to the report, which is revealing because it included not only the six crew recommendation of the 1997 Design Reference Mission, but also the four crew assessment from 1999. And they noted that, quote, no final conclusion has been reached regarding the required number of crew. So we see this note of uncertainty surfacing in the 2009 Design Reference Architecture. It also added that the mix of skills required for a Mars crew, quote, continues to be analyzed and will be dependent on the needs driven by the objectives that are set for this crew. Now, after Constellation was canceled, the Constellation program was canceled in 2010, NASA ceased formal development of the design reference architecture. In 2014, the Human Exploration and Operations Mission Directorate at headquarters chose a new direction for humans to Mars mission planning, which they called the Evolvable Mars Campaign, or EMC. Now, they described this as not a specific plan, but what they called a framework for future missions, which would include human voyages to the Martian moons, Phobos and Deimos, and the Martian surface, which they projected would begin in the mid-2030s. Now, the EMC study teams were given a ground rule of a 4-person crew. This was over the objections of some team members. And so the EMC studies effectively overturned the 6-crew paradigm that had begun in 1992. Nevertheless, if you read some of the papers that the team members published about the studies, one of those papers acknowledged the potential pitfalls of a small crew size. They said, quote, "With limited aboard options, the ability to maintain systems will be critical. There is potential that repair activities could overwhelm available crew time." Finally, we get to a study carried out in 2021 by NASA's Mars Architecture Team, the MAT. They were given the goal of finding ways to accomplish the first human Mars landing as fast and as soon as practical. So in other words, we want to cut the transit time to and from Mars, and we want to do the mission sooner rather than later, as much as is practical. So they offered a plan calling for a 4-person crew that would be split into 2 pairs. And now we're only going to land 2 people on the surface, while 2 remain in orbit in the transit habitat. The 2 surface crew land in their pressurized rover and they stay on the surface for a month. Now, really, I think the most interesting statements in the report for our purposes have to do with the astronauts who remain in Mars orbit, because they are responsible for a wide array of roles, including operating and maintaining their transit habitat, supporting the surface crew during EVAs, and providing a communications relay to Earth. But of course, real-time problems that need fast response. Basically, they don't have real-time support from Earth, so the orbital crew has to help the surface crew deal with those problems. And in possibly additional roles would include teleoperating robotic assets at the landing site and taking part in analyzing data and planning future activities in coordination with experts on Earth. So this is a very ambitious agenda for this 2-person crew in Mars orbit, and the feasibility of that agenda for the specified crew size remains to be assessed. Now, as I spoke to folks for this study, they raised a number of additional concerns and unknowns for human Mars missions, which can all be addressed using this new analytical capability that the NESC has developed. So, okay, what is the knowledge base and workload required for onboard maintenance and repair of the Mars transit habitat? So the NESC analytical tools can help guide designers to create a transit habitat whose operation and maintenance requirements would not overtax the crew. Okay, what are the pre-mission training requirements? That's an important question. Well, the NESC has laid out a systematic approach to estimating training requirements with an analytical model. Okay, ISS experience has shown that there are very real limits to the amount of information that can be retained by the crew on a multi-year mission. This directly impacts the adequacy of any given crew size and points to the need for onboard information and diagnostic capabilities to assist the crew. Well, the NESC capability does include modeling of the onboard expertise that would be required to meet primary mission objectives. And finally, past experience with Apollo and International Space Station missions shows that a Mars crew is likely to encounter unforeseen problems for which the crew would not have information on board to find solutions. This can become critical for serious problems requiring rapid response without real-time support from Earth. So the NESC capability does address the onboard expertise necessary to respond to these unforeseen failures. And I will just give you some words of wisdom that bear on how important these questions are of crew size. Yvonne Clearwater said, humans are the most valuable mission asset for the Mars exploration program and must not become the weak link. NASA JSC systems engineer and Mars mission architect Steve Hoffman said, a Mars mission is more than just Apollo on steroids. There is a quantum difference from any of our previous spaceflight experience. And with that, I will be happy to take any questions.
Thank you, Andy. That was terrific. And I think if we didn't have other jobs to do, I think many of us could spend all day talking to you about this. So thank you very much for your talk. But there are a number of questions, and so let's start going through them. And as you can see, lots of people are applauding. It's just kind of quiet on Teams, unfortunately. So the first question is from James Gilland at Glenn. And some of these missions were long, hundreds of days, state time conjunction DRM, and some were short, tens of days, state time opposition missions. Did this influence, did this influence the crew size assessments?
Not in any way that was mentioned in the reports. The only one, well, except for the 2021 study, which was explicitly tasked with carrying out a fast mission. And so they chose the higher energy, short surface stay mission in order to cut down the duration of the mission. If I have that right. I'm not sure I have that exactly right. I think it's the higher energy, short goes with the shorter stay. Maybe somebody can correct me. I do know that it's a mixed bag there because you end up with more exposure to, even though your surface stay is shorter, your transit time is longer. So you're actually exposed to the hazards of deep space radiation and microgravity longer than you would with a longer stay time on the surface. But that was the only one of the studies that explicitly mentioned mission duration and surface stay time as a consideration. And even there, it was not. I'm actually realizing I'm not answering the question you posed because even in that study, it didn't affect the determination of crew size because they were given a ground rule up front. It shall be a 4-person crew.
The next question is from Mary Lewis, also of Glenn. If the surface crew is only 2 astronauts, does that mean that one astronaut must remain in the rover or habitat while the other conducts EVA? How do you think this would affect their ability to conduct research?
Well, I mean, again, other people are a lot more knowledgeable about these questions than I am in this case, but I can tell you that the thinking has always been that you want 2 people on the surface because many tasks require 2 people, and also it's just safer in terms of helping one EVA crew person if they, if they fall down, need help getting up, whatever it is, any kind of trouble they may get into, it's good to have the second person there on the surface with them. So that's my understanding of that. In terms of the science, I mean, I think you have to think about that in the context of the broader issues that we've been talking about, which is that one person gets injured or incapacitated. With only two people on the surface, I don't even know what that would do to the mission plan, but it would certainly impact the science. I mean, again, being very success oriented raises the question, what happens if things do go wrong? What does that do to crew safety? What does that do to mission success?
Paul Shestapol, I hope I pronounced that correctly. Also from Glenn, it looks like you really got Glenn interested here. Does the cost of a mission increase linearly with additional crew members? Is there a number of crew members where the cost levels out?
I'm going to invite other people on the call to answer that if they're smart enough to answer that, because I certainly don't know the answer. I do know that there. Yeah,
go ahead.
Sorry, go ahead.
I was just going to invite someone to speak up if they have some information about this. I would say that the first one, obviously, by definition, must be the most expensive. And it has to at least slow down after that, because it's not going to double with the second person's. But does anybody have a more intelligent answer to that question?
Lee, I'm remembering, actually, if I could just throw this in, I'm remembering that we put a chart, a notional curve, and I think you were part of the conversation of creating that curve in the big NESC study report that shows not a linear rise in cost with crew size, but in fact a curve that kind of starts out more steeply and then the slope decreases. Remember that, Lee?
Yes, but I was just wondering whether there was anything more than notional about that. And I think what the question is does it actually flatten out, right? As I said, the second person is a lot cheaper than the first. And so whatever that slope is, it has to slow down. But the question is, does it ever flatten out? Is there some kind of sweet spot or something, I think is the question. Does anybody who knows more about vehicle costs and mass cost and stuff like that want to speak up now? Well, I think we should move on, but I think that was a very good question, and I think the notional answer is what Andy said, which is it does slow down. It's not linear, but that's not really quantitative answer. It's just a qualitative one.
I want to throw in another Well, no, I'll hold off, and maybe it'll be addressed by a question. So let me just wait.
Okay, so the next question is from a new center, finally. Kennedy, William Wingfield. It looks like most studies allocate some crews stay behind in Mars orbit. Is this a product of them becoming de facto mission control to provide support to the surface crew, or is the decision a product of the resources needed to get a larger crew down to the surface?
That's a really interesting question. I wish I had an answer. Again, I could only judge by what was actually written in these various study reports. I mean, the farther down you go in the gravity well, the more gears you have to turn in the rocket equation. Obviously, the more cost you assume. So I'm going to go with that as the answer to that question. I mean, even von Braun, back when he was, sending 70 people to Mars, was keeping 20 of them in Mars orbit. I think some of it may just be people being skittish about leaving the habitat unattended during the surface stay. That may be part of it.
The next question is from James Gillen and Glenn again. Is there any consideration to quantifying that quantum difference for stakeholders to understand it? I don't see that right now.
Um, I'm not sure I understand the question. In other words, the quantum
The
difference.
quantum difference between a Mars mission and Apollo, I think, is what he's referring to.
Well, I think the mental leap that some folks have yet to make is this very basic difference in the level of support to the crew. It's just once you think about it, it's really pretty clear. And in the overall NESC study, we have a graphic that shows the number of people in all of the various rooms, whether it's the mission control room itself or the support rooms in the mission control center. And there are literally dozens of people. And if you go back to Apollo, it's interesting. I recently got a graphic from a former Apollo flight director who had gone to the trouble of creating a graphic that showed the entire team in Apollo, and that even includes people in the DoD who are located at other facilities across the country, people in contractor facilities across the country. So you end up with many, many dozens of people. Our point is that you really, if you just think about the people who are resident in the Mission Control Center, in the control room and the back rooms, you have to think about those people as part of the crew. Functionally, they work as part of a Mars crew. And I think that is a leap that may be hard for some people to make, but it's an essential intellectual leap to make to really understand what's in front of us with trying to send humans to Mars. And the reason why it is so important to look very carefully at the impact of crew size on the workload of the crew, and therefore the ramifications for crew safety and mission success. When you think about the fact that past spaceflight experience pretty much guarantees multiple events per year that were unanticipated and for which there is no onboard information to find a solution. And then you think about the fact that they will not have, for a failure that requires a rapid response time, they will not have, the support from Earth. I like to say that, if you're on a Mars mission and you say, Houston, we have a problem, you may have time to go watch an episode of your favorite sitcom and come back before you get a reply. What's the problem? That's what we're dealing with.
So I'm going to switch it up here. Did Dr. Stambolian still want to ask a question, or did because he had his hand up? So I'm giving him the opportunity to ask a question verbally. Okay, he took his hand down slightly before I said that, so maybe it was answered. So let's.
Well, he put a question in the chat.
Oh, okay. I'll get to this question in chat in the queue then. So the next question is by Sergey Galkin from Kennedy, and is do the later studies take into account work being done by commercial partners on vehicle development, or the nuclear propulsion concepts that are now being revisited?
Good question, and I'm unfortunately don't know the answer. I'm sorry.
Okay, Kurosh Mirfakre, sorry if I butchered your name there. Could you please, from Kennedy, could you please provide a quick comparison of the crew size selection process between the Apollo project and future manned Mars missions, including different risk and overall mission success postures taken by NASA between these two missions?
Sure. It's interesting to note how they determined that Apollo would fly 3 people, because, that was back when they hadn't even cut any metal yet. And they looked to the Navy and the system that the Navy had of keeping watches, and they figured that a 3-person crew would allow at least one crew member to stay awake for 8 hours at a time and cover, an 8-hour watch. And so that was kind of the thinking behind sending 3 people to the moon. Now, of course, operationally, it worked out very well because they managed to design the command module, the mothership, the actual crew compartment of the command module, was able to be operated by a single astronaut in lunar orbit. And so that was a critical, design milestone that, yes, they were able to do that. And that way they could send the other 2 down to the lunar surface in the 2-person lunar lander. And again, it worked out that they were able to create a lunar module that could carry 2 people and still be lightweight enough not to bust the mass budget of the mission. So then when you go to a Mars mission, there are people, and I've heard about comments that, well, why do we even need to send 4 people? I think that again points to the need to understand this lack of real-time support from Earth, and the fact that, you're not going to be 3 days from home like you are on Apollo. In Apollo, you have a problem, and you're able, if you're orbiting the moon, let's say, and you're able to get out of lunar orbit safely, you can come home. The first time they sent humans around the moon, or the first time they sent them to lunar orbit on Apollo 8, they did it without a backup spacecraft, without a lunar lander, and part of the planning, the essential planning for that mission to give them the confidence that they could do that without a lander along was, okay, hey, we can show by test results that the mothership, the command service module, can keep the crew alive even if more than one subsystem is in a degraded state, and get them home safely. We have the option of not going into lunar orbit, and we're on a free return trajectory that'll allow us to loop around the moon and come home in a matter of a few days. When you go to Mars, there is no such abort option, right? There is no resupply capability. You can't send up spare parts. You don't have, the equivalent of the Progress freighter to bring up, backup equipment and spare parts. So you're in a whole other landscape.
So the next question is by Nicole Bellato from Kennedy. From the overview, it doesn't seem that there was a lot of focus on human factors such as isolation cycle or cabin fever. With these considered, would a larger crew size be better to facilitate relationships between crewmates? We currently do analogs with crews of 6, but personality clashes are frequent among various crews.
Yeah, that's a really good question. Actually, there have been statements kind of sprinkled all along the progression of these studies, not that many of them, but I mean, von Braun was talking about this way back in 1956 in the Exploration of Mars book. Crew members getting on each other's nerves, exactly what you're talking about, the effects of isolation. Yvonne Clearwater, before she came to NASA, had worked in high stress environments, had worked on studies of people in high stress environments with high risk and isolation. So she certainly had a background in those questions, even if they weren't front and center in her Mars surface skills study. It was definitely part of her knowledge base. More recently, the 1999 study by the mission operations guys raised the issue of having an odd number of people. They went with 4 people, and they said, well, yeah, we know that ideally you're supposed to have an odd number of people to have a person who can be a tiebreaker in case of an argument about what to do in a situation. You'd have a tiebreaker, but we're only having 4 people. But that's okay because these people will be carefully selected for compatibility. So, people have skirted this issue at various times.
So I'm going to skip to Dr. Stambolian's question because I now see it in the chat, and he asked or raised his hand very early on. So, is there any work being done towards crew sleeping more during the journey? Is there any work looking into using androids to help the crew?
Well, when you say, I'm not aware of the sleep question. In fact, I think some of the activities of the crew en route to Mars may involve training, right? I mean, we mentioned the people, the fact that ISS experience has shown that there are very real limits to what people can retain, the amount of knowledge that people can retain on a very long mission. And of course, the longest we've done is a year, and we're talking about potentially 2.5 years, something like that. So some of the activities that the crew will be carrying out on the way to Mars and potentially on the way back to Earth would be, refreshing their memories on various subsystems and various tasks, piloting tasks. They may have simulators on board. So I don't know of any comments that relate to sleeping in particular. Sorry, what was the other half of that?
Androids,
yeah.
robots.
Well, robots. I mean, I think that just falls under the heading of AI, and a lot of the conversations now about the feasibility of sending humans to Mars include a recognition that we will need AI type systems to ease the crew's workload. Now, what those systems will look like, we don't know yet. And, what the actual impact of those systems will be on crew size, we also don't know. I mean, this was pointed out, as you may remember, back in the 1963 studies, and then later in the 1997 design reference mission. Yeah, you're going to need automation, and the level of automation that you achieve will be a significant factor in determining the crew size.
So now we're in our lightning round period because we're getting close to the end. So I'm going to try to get in as many as we can. So Andy, try to be brief in the answers. So John Heese at Glenn says, what are the differences in the proposed transit times to Mars and back to Earth with conventional versus nuclear propulsion? Would you need to a larger crew size for longer time away from Earth? I know a little bit about this. The nuclear propulsion fast transit could have the total mission time of the transit part, but assuming that, would you need a larger crew size for longer time away from Earth is the question.
That's a good question. And again, I wish I knew the answer, but I unfortunately don't. I'm sorry about that.
Azita Valinia and a team have a paper in Bioastronautica from a couple of years back, I think 2023, if I'm right, which discusses fast transit. So I could point folks to that if they're interested in that. Next question is Lisa Calkins from Johnson. Fascinating presentation. In 1963, when Ames baselined a minimum of six crew, technology was vastly different. Today, with advances in hardware, the amount of required maintenance is often decreased. Did you come across any of the research discussing this? It certainly would impact crew size as less time would be needed for maintaining facilities or systems, sorry.
Yeah, I mean, I think there is a general understanding the automation of systems and subsystems would cut down the maintenance. However, even with those levels of automation, again, I'd point you to the fact that when you look at Apollo and you look at the International Space Station, you see that there is basically a guarantee of problems coming up, which you have not anticipated. And the crew will have to deal with them on board without help from the ground. That then drives a required level of onboard expertise, which then drives a crew size. Now, we don't know what that crew size is. The NESC analytical tool, we're not saying we know the answer. We're saying this is a tool to help you figure out the answer given the system that you intend to use. So, yeah, I think it's not as simple as saying technology will reduce maintenance.
Next question, Sarkis Michaelian from Dryden. I still call it Dryden, I'm sorry. Seeing how much aeronautics flight research... Armstrong Flight Research Center is its real name. Seeing how much aeronautics flight research changed our understanding of our planet, how do you envision humans flying on Mars, utilizing our extensive expertise in flight testing to understand Mars better?
Boy, I wish you were asking that question to somebody who actually knew about aeronautics. All I can tell you is they did an incredible job with the little Ingenuity helicopter, which was made as light as it could possibly be to be able to get off the ground in an atmosphere that is 0.7%, something that could fly around with people in it. I'm skeptical.
Lee, can I point out that people have put several interesting references into the chat. One is to the current people working on Mars architecture. If you're not aware of their work, it's there. And I've also put in the Zeta Valenia's work on safe transit to Mars, which answers some of those questions about propulsion and mission times.
Thank you, Cynthia. I'm just going from the top to be fair, but yes, I'm hoping to race this so we can get through this in the next minute, but I guess we're running out of time. There are Andrew Choate from Marshall put in those references that Cynthia is talking about, is there how do I filter any of these? There's one more question. This is the last question. What is your opinion on having multiple redundancy in hardware to allow time for MCC to support a fix rather than having an expert for that hardware system on board?
Oh, that's an interesting question. I haven't heard it put in just that way. I mean, that's something that can be factored into the analytical tools that the NESC has developed. I mean, as I often say, I'm not smart enough to have an opinion on that. It's certainly possible, but it would be an ideal thing to put into the analytical tool.
Well, thank you very much for sharing this incredibly informative presentation with us. I want to add one thing. I'm ad-libbing here, which is most people use up all their time and there's no time for questions. So I think everybody is super appreciative that you ended early enough so that we could have a vigorous discussion. As Cynthia said, there's a number of things in the chat that I didn't get to because I ran out of time. But once again, thank you, Andy, for your time and for this enlightening presentation. If you have any ideas or for topics and or speakers for future webcasts, you may make suggestions by going to the Human Factors Community of Practice on the nen.nasa.gov website and put in your input there. This completes this NESC Human Factors webcast. Thank you for participating today, and I hope you can join us again next time. Thank you, everybody, and thank you, Andy.
Thank you.